Hello everyone. Today I'm going to upload many videos for you guys because I'm free today and no one is home. So what I am planning is I'll upload the videos on electrochemistry which is requested, and I have already made the basics of electrochemistry. Apart from that, parallelly I'll make as many videos as possible on questions, various questions which are appearing in the exam, because most of us know the concepts and all, but the problem is because of lack of practice of the questions, we are not able to solve the questions in the exam. So from now, most of my videos will have various questions from electrochemistry, thermodynamics, kinetics, quantum, and inorganic too, which I'll be uploading on a regular basis, right? One thing I wanted to tell you is that if I put my hand here, the camera is focusing, you can observe that. So I'll try my best not to put my hand on the book. This is the problem right now with my camera. So that's the reason I have written everything on the paper without using my hand motions. I'm going to explain you what are the things I've written in my book, right? So what is the thing which I wanted to discuss today is the continuation of the electrochemistry video. So we are done with the basics. Now we'll discuss about activity and activity coefficient and mean ionic activity coefficient. Okay, see, for the electrolytes, because of the ion-ion interactions and ion-solvent interactions, what happens is that there is a deviation from ideal behavior. So there comes the need for the activity, okay? Whereas for non-electrolytic solutions, they do not deviate from the ideal behavior. So there comes the need for the activity because of the deviation from the ideal behavior. So what is activity? Activity is something which is nothing but it is related to concentration only, but it is expressed in terms of molality. So A is equals to gamma m is the activity which I have written here. A equals to gamma m, right? What is gamma? Gamma is your activity coefficient. So that's what the heading says, activity coefficient. How do you write the activity for an equation? Consider the dissociation of a univalent electrolyte represented as Ma gives rise to M plus A minus. So if you apply the law of chemical equilibrium, K is equals to the activity of the products to the activity of reactants. Right? So A is equals to gamma M. This is the first formula which you should know when we study about activity. Next, mean ionic activity coefficients. Now, for in an electrolytic solutions, we'll have cations as well as anions. Okay, so determining activity of an individual ion is not possible. Hence, we have to find the mean of the ion. I mean, mean ionic activity, which will determine by this particular method. Now consider the ionization of univalent electrolyte. Ma gives rise to M plus A minus. The cationic activity is given by A plus, anionic activity is given by A minus. Okay, so the mean ionic activity is denoted by A plus or minus and is given as activity A is equals to the product of cationic activity and anionic activity, which is equals to A plus or minus whole square, right? We are just multiplying this two, so A plus or minus whole square. For any other electrolyte of the type MXAY, so here it was just Ma in the previous case. Now I'll take Mx and Ay. So this, what you're getting is, you're just getting stoichiometries. So x m plus y a minus is the dissociation of this particular equation. Now how the activity will change if stoichiometry is there, we'll see in our next page. Right, so activity A, we know A plus and A minus, the product which we have seen here. But if x and y are included, that goes into the par. Okay, the stoichiometry is written in the superscript, that is x and A plus par x, A minus par y. So A plus or minus whole x plus y, right? Now this is the another formula which you have to remember. It's very important for CSIR, has appeared in exam once. The same equation we can write in terms of gamma also, that is your activity coefficient, which we have determined, written in the first page. The same equation you can write, gamma is equals to gamma plus power x, gamma minus power y, that is equals to gamma plus or minus x plus y. That has been appeared in CSIR once. Now if M is the initial concentration of the electrolyte, what is the electrolyte? Mx and Ay. In terms of the moles per 1000 grams of the solvent, the concentration of the ions M plus and A minus would be xm and ym. Okay, if m is the initial concentration, then what will be the concentration of the ions? It will be xm and ym. Now we know that activity is gamma m, but we have the concentrations xm and ym. We'll just replace those values in the standard equation. So we'll get x gamma plus m power x, y gamma minus m power y. Why? Because we have considered this particular electrolyte. So you will be getting even the superscripts x and y. Right. So this you can write as A is equals to x power x, y power y, gamma plus power x, gamma minus power y, m power x plus y. The whole thing can be simplified as A is equals to x power x, y power y, gamma plus or minus m, x plus y. Okay. So this is the another equation for the activity, and this you can call as the relation between the activity and mean ionic activity coefficient. So if they ask in the exam the relation between this, you have tried this formula, and they may also give you a problem based on this particular equation. So it's very important that you even remember this particular equation. So gamma plus or minus m is mean molar ionic activity coefficient or mean activity coefficient of the electrolytes. Now, by studying various electrolytes like HCl, KCl, NaCl, CaCl2, ZnCl2, etc., we have studied various electrolytes, and what is the conclusion which we get if we study these electrolytes at various concentrations? It is found that at low concentration, the mean ionic activity coefficient is closer to unity. Okay, that is the departure from ideal behavior is small. What does this mean? If A equals to gamma m, and if your mean ionic activity coefficient, okay, gamma plus or minus m, if this value is closer to 1, then activity is almost equal to concentration. Okay, that is there is no much deviation from the ideal behavior. If concentration increases, let's say there is little increase in the concentration, then the activity coefficient falls much below unity, indicating larger departure from ideal behavior. Okay, so if you increase the concentration, there will be fall in the coefficient value below unity. Now once it is below unity, it means there is a deviation from ideal behavior. On larger increase of the concentration, what happens is that activity coefficient starts increasing and in some cases exceeds unity. That is, activity becomes greater than concentration. So on further increase, what happens is that it will not fall more below unity. Okay, it will increase above the unity value, and the concentration will be greater than the activity will be greater than the concentration. Okay, this is the only case where the activity will be greater than the actual concentration, that is molality. So these are the few basics of activity and activity coefficient. Next I'll upload a video on the ionic strength, and then we'll solve questions based on the ionic strength, and after this I'll take up few questions from the chemical kinetics and I'll upload those videos by today. Right, thank you.